the last section of the normal distribution unit. So before we get into the actual notes, take a look at this problem. All right. So you were mailed a survey from Best Buy, and the survey included a request for an email address. Assume that the survey was sent to 40,000 people, and that for such surveys, the percentage of responses with an email address is 3%. If the true goal of the survey was to acquire a bank of at least 1,150 email addresses, find the probability of getting at least 1,150 responses with email addresses. So don't answer the problem. Don't actually find the probability. Just think about what kind of distribution this is. All right. So write down or pause the video and write down what kind of distribution this is and why. Then restart the video to check your answer. All right. So this problem is a binomial probability. All right, thinking back to Unit 4, this meets the criteria of the binomial distribution because it has a couple different characteristics. First, this situation is either a success or failure. Right? There's only two possible outcomes. Success would be they get an email address. A failure is they do not get an email address. And it is equal chances of a success, and that was 3% given to us in the problem. So the reason why we are looking at this binomial probability again is because we have a large number of trials. A large number of trials. If we were to write our probability statement here, the probability of getting at least 1,150 responses we're looking at a significant number. So with the probability that we get 1,150 responses plus the probability that we get 151 responses plus all the way up to the probability that we get 40,000 responses with email addresses. Right? So this is a difficult probability to calculate, and depending on the program you're using, if you're using a calculator, it might not be programmed to be able to go up this far with probabilities. So today our notes are going to look at using the normal distribution to approximate a binomial probability problem. Right? So a key thing here is n times p in our binomial distribution and n times q have to both be greater than or equal to 5. Right, so keep in mind n is number of trials, p is probability of success, and q is probability of a failure. So if n times p is greater than or equal to 5 and n times q is also greater than or equal to 5, the binomial random variable x, or the whole binomial probability problem, is approximately normal. And just like before, our mean is n times p, and the standard deviation is the square root of n times p times q. Right? So once we find out that this is approximately normal, in order to do a normal probability problem, all we need is mean and standard deviation. And we have two simple formulas to get that for us from the binomial distribution. All right, going on to the next slide. Right. This shows you a little bit of an example of why it is normally distributed when n times p and n times q are greater than or equal to 5. So in the first graph here, we have n equal to 4. All right. For all of these, p is 0.25 and q is 0.75. Right. That's given to us up here. So in the first graph, Where n is equal to 4, n times p is only 1, and n times q is only 3. And looking at that, we would say that's skewed right, so that is definitely not normal. When we increase n to 10 in the second graph, n times p is 2.5 and n times q is 7.5. Right? So still np is not greater than or equal to 5, so we still can't use the normal approximation on this graph. And you can still see that visually that's still skewed right a little bit. Not as much as the first one was skewed right, but still skewed right. The third graph, when n is 25, now both np and nq are greater than or equal to 5, and visually it's not exactly normal, but it looks pretty close to normal. And same thing with the last graph, when n equals 50, it looks even more like a normal distribution. Still not exact, but still very close. So let's take a look at our first example. So 5% of adults in the U.S. are planning to purchase a 3D TV in the next 2 years. You randomly select 125 adults in the U.S. and ask them if they are planning to purchase a 3D TV in the next 2 years. So first we want to identify N, P, and Q. Right. So looking at the problem, we are randomly selecting 125 adults, so that's N, that's the number of times we're repeating our experiment. And we want to ask them if they're planning to purchase a 3D TV in the next 2 years. Well, up here at the beginning of the problem, 5% are planning to purchase a 3D TV in the next 2 years. So our probability of a success is 0.05, and our probability of a failure is 0.95. Now in part B, we want to find the products NP and NQ and decide whether we can use the normal distribution to approximate X. So NP is 125 times 0.05. That equals 6.25. NQ equals 125 times 0.95, and that equals 118.75. Right? So we can say that this is approximately normal because NP is greater than or equal to 5 and NQ is greater than or equal to 5. Now in part C we want to find the mean and the standard deviation if it's appropriate. Well, in part B we verified that this is a normal distribution, so it is appropriate. Remember, our mean formula is just n times p, and we already did that calculation up here. We know that's 6.25. Our standard deviation is the square root of n times p times q. So that will be 125 times 0.05 times 0.95. We need the square root of all of that. So our standard deviation is 5.94. Now there's one more thing we need to look at before we can actually find probabilities with the normal distribution, and that is due to something that comes up because the binomial distribution is a discrete probability distribution and the normal distribution is a continuous probability distribution. So we have to have a continuity correction. Right? The binomial distribution is discrete and the normal distribution is continuous. So we need to adjust our calculations a little bit. Right? So both of these graphs show the discrete binomial, or a discrete binomial distribution, that would be the histogram, and the normal curve for the normal approximation. So over here on the left-hand side, we see this highlighted bar. Now, normally, using the binomial distribution, to get the probability, we're actually finding the area of this bar. We would find the probability that x equals c, and that would be the height of this bar times the width of the bar, which is always just 1, if it's x equals a value in the binomial distribution. Right? Now, to have the normal approximation, we're finding the area under the normal curve, just like any other normal probability problem, and that area is not is not a nice rectangle. Also, over here in the binomial distribution, we just enter our value that we're looking at. Whereas with the normal approximation, since it is continuous, we need to sum this whole area, and if our value is c right here in the center of that bar, we actually have to subtract a half and add a half to get the whole width of that class on the histogram. So for the normal approximation, we always have to do a continuity correction where we subtract a half and add a half. Now this does get a little more complicated because depending on what symbol we have here in the original problem, we actually have to think of the numbers that we're looking at. All right, so let's see what this actually means in some examples. All right. So we want to use a continuity correction to convert each of these binomial intervals to a normal distribution interval. So in part A, we're looking at the probability of getting between 10 and 16 successes. So we want between 10 and 16. Right? Now we have to do a continuity correction on this. And first I'm just going to list out the values we're interested in. All right? This would be 11, 12, 13, 14, and 15. So in order to use the normal approximation, I need to expand this by a half in each direction to make sure I'm including all of 11 and all of 15. So my correction is going to be 10.5 because I have to subtract a half from 11, and I'm going to add a half to 15. So this is my probability I will use for the normal distribution. In part B, we're looking at the probability of getting between 5 and 8 successes inclusive. So this would be using less than or equal to symbols this time. So if I list the values I'm interested in again, this would be 5, 6, 7, and 8. So for the continuity correction, I subtract a half from 5, so that would be 4.5, sorry. And I would add a half to 8, and that would be 8.5. So here is my new probability statement that I would use for the normal approximation. Finally, in part C, we want the probability of getting at least 21 successes. So the probability that x is greater than or equal to 21. Right? So for our continuity correction, we want 21, 22, 23, and so on. So to ensure that we include all of the probability of 21 successes, I need to subtract 0.5 from 21, so I'll be looking at the probability that x is greater than 20.5. Alright. So now try the practice problems on the back of your notes paper and then check your answers with the next video.